in our subject signals and systems, we will start with the first topic, basic signals. In the basic signals, the first one we will discuss about unit impulse signal. Unit impulse signal is denoted with delta of t. The definition for the impulse signal is its values are clearly 0 when arguments are not equal to 0. So here we used one word called augment. We are using number of times in our subject. Augment means whatever may be the value inside the bracket we will pronounce as an augment. Now its values are not equal to 0. Here please try to understand. I am not saying any value here, but I am clearly saying it is not equal to 0 when arguments are equal to 0. That is, if you take the impulse signal, its values are not mentioned, means its amplitudes are not mentioned. So what they given, the alternative definition for that, they given, yes, the area. Area under the impulse signal is equal to 1. Why? Because I written unit impulse. That is, try to understand. There are two operations are there. One is differentiation, another one is integration. Yes, we are using differentiation for calculating the, yes, please respond. We are using the differentiation for calculating the slope of the signals, and we are using integration for calculating the, yes please, area of the signal. So here I am calling area of the impulse. So area means integral. So integral minus infinite to plus infinite delta of t dt equal to 1. Suppose students, if I say 3 into delta of t. What is this 3 indicate? Please respond. Yes, this 3 indicate area of the signal. Suppose if I say 8 delta of t. What is this 8 indicate? Area of the impulse. So, whenever we are discussing about the impulse signal, students, the definition is mentioned in terms of areas. Suppose if I write delta of t minus 2, can you please say the definition? Yes, its values are clearly 0 when arguments are not equal to 0. And its values are clearly not equal to 0 when arguments are equal to 0. That is, t not equal to 2, t equal to 2. Like for example, delta of t plus 2. Yes, its values are clearly 0. Yeah, please respond. When arguments are not equal to 0. Not equal to 0 when arguments are equal to 0. Argument means, I already said in the previously, the total value inside the bracket. That is t equal to minus 2, t not equal to, t equal to minus 2. So only one point here we have to remember, students. Impulse signals are existed, arguments are equal to 0. Now let's write the graph of the impulse. Suppose, let me start with the delta of t. By the definition itself, it is existed only at a point of t equal to 0. It is existed only at a point of t equal to 0 means rest of values are clearly 0. Okay. Then what about its value at t equal to 0? He is saying not equal to 0. We don't know whether it is a 1 or 2 or 3 or 4. but clearly said not equal to 0. So that's why we are representing with the arrow. Generally, if you see in the textbooks or any of the examination, they will give you graph like this. After the arrow, they written a number 2. What is the 2 indicate? Please think about it. What is the 2 indicate? 2 indicate not amplitude, students. Please respond. This 2 indicate the area of the impulse, because impulses are mentioned in terms of areas. Like for example, come back to here. How to draw the graph of this? It is existed only at a point of t equal to 2. And the rest of values are clearly 0. Here nothing is mentioned means the value we have to assume 1. So here 1, that is the area. Like delta of t plus 2. It is existed only at a point of t equal to minus 2. So write a impulse at a t equal to minus 2, nothing is there means 1. So second point we have to understand about the impulse is, whenever if you want to write the impulse at origin, delta of t. Right side of origin, t minus. Left side of origin, t plus. Now, we will see the properties of the impulse signal. For example, students, I have some signal x of t like this. Existing from minus 3 to plus 3, amplitude is 3. This signal I am multiplying with a unit impulse signal. We already know unit impulse signal existed only at augment equal to 0. Of course, here augment to t equal to 0, and the rest of values are 0. Nothing is mentioned means 1, that is area is 1. Now I will get some resulting signal. I don't know what is the signal is coming, but I can clearly say that in the resulting signal is clearly 0, whether t value 0 plus or t value 0 minus. Why I am saying like that? Can you observe that? Because the impulse signal values are 0, either 0 plus or 0 minus. If we multiply 0 with any signal, obviously 0. Next, at t equal to 0, this signal existed. Very good. At t equal to 0, this signal also existed. Both are existed means their multiplying also existed. Right? Suppose here at t equal to 0, what is the value? That is amplitude of the signal? 3. Very good. What is the amplitude of the signal at t equal to 0? Yes, please respond. Yes, 1. Are you saying 1? I already told that is the area of the impulse. In terms of amplitude, it is not defined, students. Please observe. This 1 is not the amplitude. In amplitude wise, it is not defined. Suppose, for example, its amplitude is 2. Actually, it is not defined. Suppose, if its amplitude is 2, so 3 into 2, 6 you will get. For example, 3, 9 you will get. For example, 4, 12 you will get. But what is that amplitude? We don't know. So that's why we are writing the impulse that is going to be multiplied with the amplitude of the signal at t equal to 0. So I will write here 3. What is the meaning of that? We are having a impulse at t equal to 0. So delta of t. This is going to be indicating the area. So 3 into delta of t. That is, what I observed is, I multiplied the x of t with delta of t. I got 3 into delta of t. If you clearly observe, student, can you say what is that 3? That 3 is nothing but value of the signal. Yes, please respond. Value of the signal at t equal to 0. Value of the signal at t equal to 0 means, can I say x of 0 into delta of t? That is a wonderful. The first point, what we have to understand in the properties are, any signal, here x of t may be any general signal, student. Whatever may be the signal, if we are multiplying with our impulse signal, replace always where is the impulse existed. Always impulse existed, arguments are equal to 0. Argument is t equal to 0 here. Replace in the second function. So, x of 0 into delta of t. It will come throughout our subject. Like, in the same consequence, can you say the answer for this? X of t into delta of t minus t naught. Of course, t naught is constant. Yeah, what is the answer? Yes, someone is saying x of t naught. Very good. How you got? Whatever may be the signal, multiply with impulse, replace where is the impulse existed. Impulse existed, argument equal to 0. T minus t naught equal to 0, then t equal to t naught, replace in the second function. If you are not getting, see the third one. X of t multiplying with delta of t plus t naught. Yeah, the answer is x of minus t naught. Very good. Next one is fourth one. Integral minus infinite to plus infinite x of t into delta of t dt value how much? That is, we just now seen in the property number 1, any signal multiplying with impulse, replace where is the impulse existed. Impulse existed, argument equal to 0, that is t equal to 0, replace in the second function. So, integral minus infinite to plus infinite x of 0 into delta of t dt. What is the meaning of x of 0? We seen in the previously. The meaning of x of 0 is the signal value, that is amplitude at t equal to 0. So, amplitude means it is a constant. Amplitude may be 2 or 3 or 4 or 5, any value, that is it is a constant. So, constant I can write outside. Then if I write the constant outside, please clearly observe what is remaining in that integral. Integral minus infinite to plus infinite delta of t dt means area under the impulse. What is the area under the impulse? Nothing is there, means 1. So x of 0 into 1, that is its value is x of 0. In the same manner, can you say the answers for these two questions? Integral minus infinite to plus infinite x of t into delta of t minus t naught into dt, first one, and the next one, integral minus infinite to plus infinite x of t into delta of t plus t naught. Yes, most of them are getting answers. What is the value for this? Delta t minus t naught, what is the value? X of t naught. For this one, x of minus t naught. Replace the signal existed right outside, remaining area under the impulse is 1. Next one is delta of minus t value also delta of t. Why I am saying like that? Why delta of minus t value also delta of t? We just now seen impulse is existed, augment equal to 0, that is t equal to 0, replace. Delta of minus 0 equal to delta of plus 0. Is anyone is saying any difference between minus 0 and plus 0? No, there is no difference. So, between minus 0 and plus 0, no difference. So, delta of 0 is equal to delta of 0. So, this is going to be valid. So, that's why delta of minus t is a delta of t. Because of that, we can also call it is a even signal. Of course, still we are not discussed about even and odd, but you can remember x of minus t equal to x of t, it is called even or symmetrical signal. Like next one, delta of at, where a is a scalar and a is a scalar and a value may be positive or negative. It is nothing but 1 by mod a into delta of t. That is for your clear understanding. Suppose if I have delta of 2t, its value is 1 by mod 2 is 2 into delta of t. Suppose if you have minus 2t, 1 by mod minus 2. Of course, mod minus 2 means 1 by 2 into delta of t. So that's why I said here a may be positive or negative. The result will never change. So remember these 8 points about the impulse signal. There is a one question is asking 1 mark, and sometimes it is also asked for 2 marks question from the properties of the impulse. Yeah. Just now, one of the student is asking that how I written delta of at value is 1 by mod a into delta of t. Here we are preparing for our competitive examination, so that's why I am not deriving that. If you want personal, you can ask. Just here from the derivation you can bring out, but I written here directly. Please note it. Up to now, we've seen about the impulse signal and its properties. Now we'll see the problems on the impulse signal. So please note down. First one, integral minus infinite to plus infinite cos pi t into delta of t dt. Second one, integral minus infinite to plus infinite sin pi t into delta of 2t minus 3 dt. Third one, integral minus infinite to plus infinite sin pi t into delta of minus 2t plus 3 into dt. Fourth one, integral minus infinite to 2 cos pi t into delta of t minus 3 dt. Solve the 4 problems. Yeah, come to the first one. If we see the property number 4, any signal multiplying with, that is integral minus infinite to plus infinite x of t into delta of t dt is nothing but I said x of 0, that is cos pi into t value 0, cos 0 1. Then see the second problem. How to handle such type of problems are, first point, if there is any scaling factor, So first avoid that scaling factor. Then go for the property number 4 or 5 or 6. That is integral minus infinite to plus infinite sin pi t into, take 2 common, 2 into t minus 3 by 2 into dt. We see in the property number 8, delta of bt is in total you can treat as a t. Delta of at value is nothing but 1 by mod a into delta of t I told. So sin pi t into 1 by mod a. So 1 by 2 into delta of t. So t minus 3 by 2 dt. Now see the 1 by 2 is a constant outside. See the property number 5. Integral minus infinite to plus infinite x of t into delta of t minus t naught is x of t naught. So sin pi into t naught value 3 by 2. What is sin 3 pi by 2? Minus 1. So minus 1 by 2 is the answer. So whenever there is a scaling factor, first apply the scaling factor, later you can go for the remaining things. Now see the problem number 3. Can anyone got the answer for problem number 3? Yes, someone is saying 0, okay. Someone is saying yes, 1, okay. 1 by 2, okay. Let's see the answer. Some 3 options I got up to now, 0, 1 and 1 by 2. Let's see what is the correct one. And is there any 4th option is coming? Let's see. And the third problem, if you are observing, for t there is a minus. So time reversal is there. We see it in the property number 7, delta of minus t is delta of t. So first avoid that. Means first apply that impulse, first apply that reversal, then later go for it. So integral minus infinite to plus infinite sin pi t into delta of, take minus common, so 2t minus 3 into dt. Just I take a minus common. We know in the property number 7, delta of minus t value. Yes, please say the answer. Delta of minus t value is delta of t. The whole you can treat as a t. So integral minus infinite to plus infinite sin pi t into delta of 2t minus 3 dt. Can anyone say now the answer? Yes, exactly. Minus 1 by 2 only. Why? Exactly, this is a second problem only. If you guess. So, after avoiding the reversal, how to proceed? Later take 2 common scaling. Next apply the property number 5. Next see the question number 4. Can anyone have the answer for 4th question? Yes, its value is 1. No, minus 1, okay. 0, okay. Any other individual answers? Yes, please see. My answer for the 4th question is 0. Why my answer is 0 for 4th question? Can anyone guess? Here, try to observe. If you see this problem, I will substitute 3 here, cos 3 pi. Cos 3 pi is minus 1. Why you written 0? Here, the first point you have to understand, student, where to where you are integrating and where is the impulse. Here impulse is at 3, you are integrating only up to 2. Means you are not including the impulse. If you are not including the impulse, What is its value? Is 0. 0 and anything will be 0. So total thing will be 0 because where is this existed? This existed only at a point of t equal to 3 and the rest of values are 0. You are integrating from minus infinity to 2. Over minus infinity to its value is 0. 0 and anything will be 0. So whenever you are evaluating these integrals, 3 points keep on your mind. First point, whether in the given integration limits, impulse is included or not. If not, total value 0. Let's view the problem. If included, second one. Is there any time reversal one? First avoid it. Time scaling, next. Then either it will comes in the property number 4 or 5 or 6, directly you will get the answer. Of course, the first problem is the GATE 2002 question for 1 mark. Second one, we will discuss about unit step signal. Unit step signal denoted with u of t. This is it. Second one, unit step signal. Unit step signal denoted with u of t. The definition for u of t is, students, its values are 1 when arguments are greater than or equal to 0, 0 when arguments are less than 0. I will draw the graph. You will get still more clarity over that. Its values are 1 when arguments are greater than or equal to 0 and 0 t value, that is argument, less than 0. That is, here if you observe the step signal is defined in terms of their amplitude. Why I written 1? Because I said unit step. Like for example, if I have u of t minus 2 or maybe u of t plus 2. Yes, its values are 1 when arguments are greater than or equal to 0. 0 when arguments are less than 0. Here also, its values are 1 when arguments are greater than or equal to 0 and 0 when arguments are less than 0. That is, here what is the t? Greater than or equal to 2 onwards, t less than 2. Here t greater than or equal to minus 2, t less than minus 2. If I draw the graph of the u of t minus 2, yes, it is starting from where? Please respond. It is starting from t equal to 2 onwards. Yes. From t equal to 2 onwards, its values are 1. And this one starting from where? Minus 2 onwards. So, u of t plus 2 starting from minus 2 onwards, its values are 1, before its values are 0. So remember 2 points about the unit step signal or step signal. Its values are existed when arguments are greater than or equal to 0. Second point, if we want to write the step signal starting from origin u of t, right side of origin t minus, left side of origin t plus. see the some of the properties of the step signal. Suppose students, I have a signal x of t equal to e power at, where a is a scalar and it is a positive one. So let me draw the graph of this signal first. First I am writing on right side. Means t greater than 0. Means positive values of t. T is positive, a already positive. Positive into positive, positive. E power positive. E power positive means like e power 1, e power 2, 3, 4, 5. If I am moving like that, values are increasing or decreasing, students? Yes, values are increasing. So, are you moving towards the right? Value is increasing. At t equal to 0, its value 1. Now see on the left side. Left side means t values are negative. A is inbuilt positive. Negative into positive, negative. E power negative. E power negative means e power minus 1, e power minus 2, minus 3, minus 4 and so on. If you are moving like that, values are increasing or decreasing? Like e power minus 1, 1 by e, 1 by e square, 1 by e cube. Yes, someone is saying value is decreasing. Yes. So if you see overall the signal from left to right, because we are moving from past, present, future. Always in our subject signals are moving from left to right. So if you are moving from left to right, it is exponentially increasing. So we can also call this is exponentially increasing function. Where this A is also called the rate or also called time constant. Now, this signal I am going to be multiplying with our unit step signal u of t. U of t existing from 0 to infinite, its values are 1. Now I will get a new signal. I can clearly, I can say blindly, that signal is existed only for t greater than 0. Left side values are clearly 0. Why left side values are clearly 0? Our step signal value is 0 for t less than 0. 0 multiplying with any signal, 0. What about the right side value? Yes, please see. What is its right side value? 1. And multiplying with some signal. Anything multiplying with 1, 1 is the identity number with respect to multiplication. X of t multiplying with 1, x of t only. So, same variation on the right side. So from this discussion, students, what you are observing, any signal, if you are multiplying with the unit step signal, only the variation of the signal existed on the right side and its complete left side variations are becoming 0. That is, if you want the variation of the signal only on the right side, multiply with u of t. Now we will see the problems on the step signal. Number of times asked in the GATE examination as well as in engineering service examination objective paper. Even in conventional also this part is needed. The first question is, represent the following signal in terms of the shifted unit step signal. they given the problem x of t like this, which is existing from 0 to 2 like this. One, here value is 2. Now this signal we need to represent with the unit step signal. First point you have to understand, student, the meaning of step is, if you see whether u of t or t minus 2 or t plus 2, whenever there is a sudden change in amplitude, whenever there is a sudden change in amplitude step, that is called the step signal. So here at what values of time we are having sudden changes in amplitude, sudden change. For example, at t equal 0, suddenly amplitude changing from 0 to 1. At 1, 1 to 2. At 2, 2 to 0. So wherever there is a sudden changes in amplitude, there is a step signal will present. Like u of t at 0, t minus 2 at 2, t plus 2 at minus 2. There is a sudden changes in amplitude. Now, wherever there is a sudden changes in amplitude in the given signal, the meaning is there existed a step signal. So we have sudden changes at 0, 1 and 2. So please write the step signal at those instants of time. Step signal at origin means u of t. At 1 means right side t minus, left side t plus I told. Sudden change at 2, t minus 2. After that, what are the coefficients? Coefficients are nothing but amount of change. Remember students, always change means final value minus initial value. So at t equal to 0, final means always right side value. At an instant of time, right side is called final, left side is called initial, because we are moving from left to right. So at t equal to 0, final value means right side 1 amplitude, left side 0, 1 minus 0, 1. Next, at t equal to 1, right side value 2, left side value 1, final minus initial 2 minus 1, 1, 1 means plus 1 only. At t equal to 2, final minus initial, right side minus left side, right side 0, left side 2, 0 minus 2, minus 2. That is a representation of the given signal in terms of step function. Some of them are seeing with a confused face. Let's take the one more problem. We will get the clarity over that. Suppose they give a next one x of t like this. That is the second problem. Now, how to represent with the step signal? Wherever there is a sudden changes in amplitude, I told, represent the or write the step signal. At what values of time you have sudden changes in amplitude? At 1, 2 and 3. So, write the step signal at 1. 1 means t minus 1, 2 means t minus 2 because right side. 3 means u of t minus 3. After that, what I told? Write the coefficients. Coefficients are nothing but amount of change. Change means final minus initial. 1 minus 0, 1. At 2, final minus initial. 2 minus 1, 1. 1 means plus 1. At 3, final minus initial. At any instant of time, please understand, right side values are called final, right side amplitude, value means amplitude, left side is called initial. So 3 right side amplitude 0, left side amplitude 2. Final minus initial. That is a representation of given signals in terms of these shifted impulses. And one more important note point you have to understand here is very important point. Number of times it came in GATE examination, even 2 marks question. Here, what is the duration of this signal or maybe this signal? Duration means how much time it is becoming a non-zero. Yes, it is existed for 2 seconds. Of course, this is also for 2. 2 is a finite number or infinite number? Finite. So, any finite time durated signals, not only 2, maybe 3, maybe 4, 5. Any finite time durated signals if you take, and if you are representing by the step signals, please add the sum of the coefficients. Please add the coefficients. How much is coming the answer? Please respond. Yes, you are getting the value is 0. So, if it is a finite time durated signal, if we are representing with a step signal, sum of all the coefficients are 0. Or if the sum of the coefficients are 0, the given signal is a finite time durated signal in the step signal representation. Remember. Third one, we will discuss about unit ramp signal. Denoted with R of t. Definition for R of t is, it is a different one. Its value is augment itself. When augments are greater than or equal to 0. 0 when augments are less than 0. If I draw the waveform of this ramp function, clearly for t less than 0, its values are 0. From 0 onwards, its values are augment only. That is t equal to 0, 0. T equal to 1, 1. T equal to 2, 2. 3, 3. Because its value is t itself. That is 1, 1, 2, 2, 3, 3. Means from 0 onwards, it is increasing. Like for example, I have R of t plus 2. Its value is t plus 2. When augments are greater than or equal to 0. 0, augments are less than 0. That is t greater than or equal to minus 2, t less than minus 2. That is, if I draw the waveform of the signal R of t plus 2, starting from minus 2 onwards, before minus 2, its values are 0. Let's take this is minus 2. From minus 2 onwards, increasing. Can you say, what is its value at t equal to 0? Can anyone say the answer? Substitute t equal to 0. 0 plus 2 will be 2. Can you say its value at 1? T equal to 1? How to get? Substitute in the equation. 1 plus 2, 3. Like that. Same if you want to write R of t minus 2. Yes, it is t minus 2 when augments are greater than or equal to 0. 0 when augments are t minus 2 less than 0. Now follow. Suppose I have a signal x of t equal to t, just like y equal to mx. Here m value is not mentioned, means 1. How the line y equal to mx line? It is passing through the origin. Nothing is mentioned means m value is 1. So slope is 1. This is going to be multiplying with the unit step signal. Unit step signal means it is existing from 0 to infinity. Its values are 1. Less than 0, its values are 0. Just now we seen any signal multiplying with the unit step signal, only the variation on right side is existed. Its complete variation on left side will becoming 0 because it is existed only on the right side. If you are able to observe this, what is this? This is nothing but x of t multiplied with u of t. What is x of t? T. T multiplied with u of t. If you are able to observe, this is looking like a r of t waveform or not? Please observe. Is there any difference between these two? No. Same as r of t. That is, first point I am saying, ramp signals are existed, augments are greater than or equal to 0. Second point, here I said unit ramp. What is the meaning of that unit? Is its amplitude is unit? No. It is increasing one. Is it area is unit? No. Total area is infinite. Then what is unit? That unit is nothing but, it means 1 is nothing but the slope. That is, ramp signals are defined in terms of slope. Impulse signal area, step signal amplitude, ramp signal slope. That is, r of t is nothing but t into u of t. R of t minus 2 is t minus 2 into u of t minus 2. R of t plus 2 is t plus 2 into u of t minus t plus 2. Like how many you want, you can implement like that. Because sometimes in problems it is necessary to convert ramp signal in terms of step signal. See one problem on the ramp signal. Suppose I have a x of t like this. I want to represent the signal by using the ramp signal. In the previously, we are representing with the step signal. How? We are writing the step signal wherever there is a sudden change in amplitude. Now, when come to the ramp signal, reference is slow. So, you have to write the ramp signal wherever there is a sudden change in slope. So, first calculate the slope of the signal at each and every point, at each and every section. Slope means simple word, change in y-axis by change in x-axis. Change in y by change in x is nothing but the slope. Suppose, what is the slope of the signal before minus 5? There is no signal, no slope. Now I am calculating from minus 5 to 3. Change in y is 4. Change in x is 2. 4 by 2, 2. Increasing positive, decreasing negative. Minus 3 to plus 3. Minus 3 to plus 3, is there any change in the y-axis? No. 0. 0 by anything? 0. Are parallel to x-axis, slopes are 0. 3 to 5. See, change in y 4, change in x 2. So 2, 4 by 2 is 2. Decreasing means negative. After 5, no signal, 0. All those are slopes. So wherever there is a change in slope, tell me the t values. At what values of t there is a sudden change in in slope. At I can say at -5 because 0 becoming 2. Next at -3 because 2 becoming 0. Next at +3 because 0 becoming -2. Next at 5 because -2 becoming 0. So wherever there is a change in slope, write the ramp signal. So change in slope at -5. So r of t plus 5. Left side t plus. Next slope change at 3, t plus 3. Next at 3, r of right side t minus. What are the coefficients? Amount of change. Change means final minus initial. At -5, final to initial 0. 2 minus 0. At -3, final minus initial 0 minus 2 minus. At 3, final minus initial right side value, left side value. -2 minus 0 minus 2. At 5, final minus initial 0 minus of -2 will be +2. So write the ramp signal wherever there is a sudden changes in slope. Coefficients are nothing but amount of change. Now see the relations between impulse signal, step signal and ramp signal. In the previously we studied about ramp, step and impulse individually. Now we'll see the relation between all those three signals.